All right, go ahead and get started. Glad you guys stuck around towards the end. Literally last talk before we have the final panel. I'm going to be talking about obviously some mobile hacking, iOS, Android. We'll be talking about some of the goals with regards to pen testing, taking apart apps for both platforms as well as hybrid applications, and we'll talk about just generally the definitions of hybrid, native, and things like that. But first, my name is Guzman. I am based in Los Angeles. I'm a pen tester. I work for Screwups. I am a board member for OWASP Los Angeles and also the president of Cloud Security Alliance Southern California. So if you guys are ever in the area, we have monthly meetings literally every month, and we hold, if you guys are in California for, let's say, January, we have our AppSec California. Right on the beach, Santa Monica. So if you guys are on the East Coast, anywhere with snowing, come to the beach, West Coast, always great. Great talks. We have, Sammy Kamkar and Charlie Miller. I think those type of stunt hacker guys. But aside from that, enough about me. Again, this is some of the things: Android fundamentals, iOS. I'm going to go through some demos and some tools I'm going to introduce. So hopefully by the end of this talk, you guys can at least do 70% of an assessment. And the perspective we're gonna go off of is more of a pen testing perspective, where you get an application rather than acquiring it from a third party or things like that. So there's three open source tools that I'm gonna demo, all free, all on GitHub, and you guys can grab those, and then we'll get some questions, fit those in. So half of it will be kind of talking, and half of it will be demo. So hopefully you guys we can see what's going on the screen. But so with Android, most everybody probably knows it's based off of Java. It's not your regular Java type of applications. It's a specific version for Android, and the reason being is the regular Java, like JSP web application, things like that. You have a JVM, and which is a virtual machine where things are compiled and things like that on runtime. So Android, you have a Dalvik VM and the new Android runtime VM. And the main concepts for Android are activities, intents, services, broadcast receivers, and content providers. And activities are basically just the screens you see when you open up an app. Intents are basically do actions behind the scenes. So I have an activity. I want to perform some sort of action. I'll have the intent to do that action. And a broadcast receiver can be something like a notification service. And content provider could be like a SQLite database, or sharing that to a third party, or delegating that to another app within the same developer. And just the general review process of Android applications are different than they are in iOS. And we'll go to iOS in just a second. But for Android applications, you submit them to the Google Play Store. And with Google Play Store, you have the Google Bouncer. And the Bouncer just checks for malware activity, puts them in a sandbox, basic type of checks, backdoors, things like that. Nothing as strict as Apple, like I said, we'll get to in a bit. But it's kind of just low-hanging fruit type of testing, nothing sophisticated. A lot of research projects to say from like master thesis of universities will kind of end up in a Google Bouncer like practically. So here's the basic like form of an Android like kind of configuration file, which would be the Android manifest, and this is where the permissions are set. This is where the activities, the services, the intents, broadcast receivers, everything I discussed in the previous slide is all right here in this XML file. And when you take apart an app, the first thing you'll see, I'll go through kind of taking apart an app as well. You'll see a series of XML files, just key value pairs, as you can see here as an example. Sometimes you'll find clear text passwords. You'll find secret codes, as in you press 1357 on your phone, something will prompt up, things like that. So this is usually like step one, what you want to look at within an Android application. But again, this is where all the permissions are set, all the content providers and things like that. And again, content provider would be, I want to give someone access to my database or my application sandbox, put it that way, which doesn't sound safe, right? So So iOS is based off of Objective-C primarily, and also Swift. But what it is basically a messaging language. So it's like, hey, you want to tell me to do something? Okay, let me pass it over to on runtime to this what's called Objective-C message send. It just sends everything through here. So if you have GDB, if you have any other type of debugger, and you just hook for Objective message send, you'll get everything that's getting sent over to the kernel and back and forth. So with Swift is the same right now. It's you don't have to. You can build them with Objective-C and Swift as far as applications together. And iOS, the same thing as Android. They created like Google's created Android classes for their Android framework, and same thing with iOS to like for touchscreen. We'll go through it in just a second, but you have touchscreen media. And things like that that Apple exposes their APIs to. So you'll have public APIs, private APIs, and that's also within the Apple review process. Any application that gets submitted to the Apple Play Store, the App Store, will go through a series of checks more stringent than the Google Bouncer. So one thing would be if an application is using a private API for Objective-C, it'll get denied right away. If it's using an old OpenSSL library, it'll get denied right away. Obviously, if it has some sort of backdoor, some sort of malware activity, get denied right away. If it's using a vulnerable framework, which we'll get into frameworks as well, get denied. It's much more strict. They'll go and send out notifications to all application developers, let's say, or owners, if there's a big vulnerability, say OpenSSL or even another framework, Bolts or things like that. So again, layers is what Apple does. So Cocoa Touch is touchscreen, all input. Media would be speakers, things like that. Core services would be like iCloud, for example. And Core OS is all the kernel level, based off BSD, things like that. And they give you when the application runs within an iDevice, would be iPad, iPhone. It runs in a sandbox. And this is during runtime. You'll have a sandbox here where you have your main app, your container, and you'll have documents, which is kind of where the SQLite databases lie. You'll have your library, your temp directory, your library will have your cache information, and you have your iCloud container. But when you take apart, when you get an actual binary of an iOS application, it's an IPA file. So .ipa, and all it is just a zip file. Same thing for Android. They're APK files. Just rename it to from app.apk, app.ipa. So I'm going from Android and iOS to app.zip for both. And all you gotta do is extract that. And once you extract that for IPA files, this is the structure. It'll automatically create a payload directory. And within the payload directory, there is the application name, which would be over here, application name.app. And you'd want to go into that directory, and there's a binary of the raw binary for the application. So that's what you would get, drop into IDA, for example. You could see all the classes, all the functions. So it's not that difficult. It's not impossible at all. It takes just as fast as it does for Android applications to take them apart, look at the code, and we'll go through that right now in just a sec. So equivalent to Android's Android Manifest XML, iOS applications have what's called the info.plist. And again, it's the same thing. It's an XML key value pair. This is how it looks within Xcode. And it just creates the XML file for you. But it's the location where you have, say you're asking for certain permissions, you'll actually write a description to Apple why you want these permissions. And same thing, plenty of times, time and time again, I always see passwords in here, or let's say blowfish encryption, secret keys, private keys. You'll see some interesting information. So this is, again, the first step that you'll want to look, or first file you want to take a look at is the info.plist. And it's just, again, just a general configuration file that that the app looks at to see if the application has any kind of extensions. So if anybody has any, like an iDevice, an iOS phone, and you hold it, it opens up in Twitter or opens up in your photos or things like that. It's an application extension. So that's something that's got created with, I think, after iOS 8. And it'll be defined here in the info.p list. So we'll go through just the building blocks of Android framework. Now, I did forget to ask, has anybody researched mobile or pen test mobile applications? Cool. A couple people, 3. Okay. How about web applications? It's usually the same. Okay, cool. Cool. Anybody do it just for research, general, curious, want to learn a lot more? Okay, cool. So I'm not going to go through from the bottom up from the Android framework. What I do want to focus on is the difference between Android's kernel and a regular like Ubuntu kernel. And what that is just what's called the binder. And the binder is what Android uses for inter-process communication, IPC. It's basically like a proxy. So you have process A here, process B, binder. And process A will talk to the binder, and binder will talk to process B, depending on permissions. And the kernel checks the permissions. I think it's the user ID and group ID as well. So the kernel does a lot of the heavy lifting for permissions and also IPC, inter-process communication. But that's kind of the whole takeaway from this. It's built-in layers, obviously. You can see with the libraries and Android framework here where we talked about providers and managers and things like that, as well as applications. Another thing kind of to know is with applications, you have system applications and you also have user applications. So system applications are the ones you can't delete unless you're root. And those are installed in like /system apps. But that's just, it's not anything to do with security. But again, we talked about the runtime. There's some native libraries, but they're not as important as just knowing the differences between the kernel. And obviously Android's built more for embedded systems. And here is iOS type of architecture for their devices. And I just want to just explain or show that the separation between hardware, software, and how the container, as far as where your passwords are stored in keychain, it's stored in the secure enclave. Secure element. Secure enclave is for Touch ID, and you also have your group keys, things like that. Your root certificate, which Apple obviously has. We had the whole San Bernardino cracking iPhone scenario recently. And your phone, obviously, after iOS 8, your phone is automatically encrypted at rest. So there's called data protection APIs, and those data protection APIs use these keys here at the kernel level. So Apple's built that in by default for newer iDevices and iOS versions. So we'll talk about native frameworks, hybrid frameworks, and what they basically are is you have iOS, and you have Android, and you have hybrid, which is basically web technologies that combines both iOS, a code base, and also Android, and HTML5, JavaScript, CSS, and how that's exposed is via web views or in-app browsers, for example. And just think about, you have not only native vulnerabilities, you have web vulnerabilities as well. So a lot of it is mostly JavaScript injection for hybrid vulnerabilities. And we'll go through the frameworks, the common frameworks and builders, and why you'd want to think about researching documentation and developer disclaimers that these builders and frameworks provide you. And just it's ridiculous. We'll go through them right now as far as the example. So again, it's like web app-ish. You have client-side, heavy JavaScript, doing a lot of the heavy-based work. Everything's going JavaScript nowadays, client-side. You have Node.js, you have Angular. And again, one code base. So you can have Android and iOS update without even redeploying. It's all web, so it's like a web app. There's no submitting to the Google Play Store. There's no submitting to the App Store. There's not a review process. Once you submit and get accepted, you can do whatever you want as far as a hybrid application is concerned. So they can have vulnerable APIs and still get away with it. So a big key takeaway here is you don't have to redeploy with the hybrid app. The native app you do, which 2 days for the App Store and like a day for a Play Store. And again, native, Objective-C, Swift, the native language C, C++. Generally better security, only because you have more control over the code and functions and what you can do with it. With frameworks and hybrid, it's mostly just frameworks. You have someone who's already pre-written code, templated out, and it's almost a building block. They're just building blocks. And we live in a time today where you can drag and drop and build not only web applications, but mobile applications. So it's very, very simple and cheap and fast. So with HTML5, you have technologies like WebSockets, and you have to be careful when you're testing for WebSockets, because the way you tether and the way you proxy for network API testing, sometimes it works, sometimes it doesn't. As far as the only way I've gotten an iOS application and proxy and see WebSockets is if I do it via Bluetooth. If I do it via Wi-Fi, I can't see WebSockets. Not sure why, but I was talking to guys from Invisium, and they share the same headaches with WebSockets. But something to keep in mind. There's local storage. So not only do you have cache, temp, SQLite databases, but you also have local storage, which is persistent on disk. And a lot of tools, free tools out there, don't look for local storage. They just look for cookies, cache, databases, SQLite databases. And for iOS, there's something called Realm databases as well. You have to have a specific application to view those. But these are also just generally the attack surface that's expand from just native mobile apps to hybrid. And WebRTC is a pretty cool technology, but it's also a huge risk. A lot of unified communications applications use WebRTC. It basically just pierces right through, traverses your firewall, and it uses almost like a reverse call, so it can open up that port and send traffic through it peer-to-peer. So a lot of privacy concerns with WebRTC and file system API, just by the sound of it. It's not great. But another thing is, which is pretty cool with HTML5, I'm not sure if you guys have heard of asm.js. You can now compile applications like real time with JavaScript on a website. There's so much more to worry about. So the main and probably most important framework that people use, or common framework, is Apache Cordova, which was known as PhoneGap. And what these Apache Cordova, a lot of other frameworks hop on the same bandwagon and use Cordova's type of technology, but they have, instead of using like a WebKit runtime, it'll use Crosswalk. And again, you'll have to update your runtime for web views, and you're relying on the Crosswalk kind of code base, which is open source, community based, to be updated. So here's just some examples of advisories. I know you guys can't see, and it's not supposed to be, so you guys can read this. It's just to show you from last year to now how many high and medium vulnerabilities have been disclosed for Cordova. And I think there's 3 high and 4 mediums here. So these are, some of them they're high if they are like remote code execution, or even HTTP whitelist bypassing, which might be over here. I can't find it. We'll find it here. It is this one. So what that means is basically JavaScript injection. When you're with a Cordova application, you have an XML file, again, for a configuration file, right in the root of the application bundle or application directory, sandbox. And you can also check for that too. There's passwords in there sometimes. But this is just to show you, just within the year, you have 7 high and medium, remote code execution, JavaScript injection, which is cross-site scripting, which can also give you not only JavaScript code execution, but also Java objects within the application sandbox. Yeah, and this one specifically is with regards to Android intent. So this is for Android and iOS, and there's more than this. This is just off of their changelog and their update page, just searching for security. And there's plenty, and there's still more to come. And you'll see right here that they have their own kind of package managing system, which we'll get to in a bit. But again, expanding that attack surface, which is actually right here. You can publish your own plugins for Cordova. And what these plugins are, they give apps native access, basically. You can. But anybody can publish a plugin and anybody can use it. And it's based off of NPM. So if anybody was paying attention to the news lately with regards to NPM and how some guy kind of rage quit, took off his 17 lines of code and broke every build, think about how you can just use your own plugin that is not reviewed, by the way, by anybody. You can just pull it down, install it. Any developer is going to use it. And then essentially just name it something like calendar.js, whatever, and make it, probably legitimate, and then put a couple lines of code that are not. You do plenty with it, but the point is you have your own packaging managing system, no code review process. Anybody can do it. You can use it. It's all dynamic, all during runtime. And it even tells you a plugin is a package of injected code that allows the Cordova web view to render communications. Like, it tells you right there what it does. So it's not great. Yeah, there's the example. 17 lines of JavaScript and broke the internet. You might not even know when you're building an application, a lot of applications use NPM, even if the code base is not even using like Node.js, for example. You would think NPM, Node.js, but plenty of big companies use NPM for their package managing and build system, even for Android. So another framework is Ionic. Again, HTML5, JavaScript. It's heavy on Node and Angular, and it hops on the Cordova bandwagon using their runtime, using their plugins, but also gives you additional APIs. So people are just basically rolling out their own frameworks and their own things that make life easier for them to build applications. So here's an example of some vulnerabilities within Crosswalk, mostly to do with OpenSSL, confidentiality, and encryption. So I would say second most common would be Xamarin. If you know how to write C#, you can write a mobile application with Xamarin. And what it does is it uses what's called Mono, so you can run C# and .NET kind of framework on a Linux platform, being Android, as well as iOS. So the interesting thing is that they have their own IDE, they have their own package managing system as well. So they have their own issues, but they just translate C# over to Java and over to Objective-C. So what this example is showing right here is it's demonstrating that by default, ISSL security checks are disabled. And this is straight from their Xamarin website here. I found a bunch of cool things with Xamarin. They used to, this was about last year this time, May 19th, they stored their DLL on the SD card where all applications can access DLL, their library. And from there, you'd pull it, make some modifications, hijack it, and then any type of app, you could hook it, do whatever you want at that point. But just generally, not a good idea to save anything in the SD card for Android devices. So I found another cool thing. It's open source, Xamarin, although you have to pay to use their backend services. But just going around through their GitHub, I found that they have hard-coded their key store password for all the accounts that use Xamarin applications. So it's right here, nice little string of hard-coded password right in GitHub. Anybody can see it. It was reported in 2014, and I saw somebody comment last month saying, "Hey, I think we should look at this again." So you'll see, you'll not only see this, you'll see this password for Keystore. So Keystore, you can store certificates, and you could also store passwords. So just think about that. That's pretty important to not have hard-coded for every single app that uses Xamarin, not just one company. This is from their main branch here. So Kendo UI, primarily backend is .NET, ASP, but they also have integrations with JSP and PHP applications. It's more for just migration, people to have the ability to use their platform. And when I say they, I'm referring to Telerik. And Telerik it's great. They're again drag and drop type of builder, and they have their own backend as a service. Super simple. Click tells you want to put a drop. You want to put a form here, authentication form. How do you want it to validate it? Does your whole access controls. You can create an app in like a week, literally. Upload some images. Really simple. And they also have ability to test and deploy your application like right away. And you can also, they have their own kind of VM where you can test the usability of your application in Android and iOS at the same time. Really cool, but obviously, easy and rapid development means there's going to be some issues, and we'll go through those right now. You could just tell by these arrows and everything else I kind of filled in that we have a lot to go over. So from their documentation page, this is more of a suggestion and guidance for them to how to build secure code, secure applications, what to do in certain scenarios. And what they're recommending to people who are developing applications is they're saying keeping the applications out of hackers' hands, and meaning to not submit your applications to the App Store or the Play Store, but yet use Telerik's App Manager, because this provides you with 100% control over who has the ability to install your app. But come on. That is not the case, not at all. There's so much that they're missing as far as, we went through the App Store checks, Google Bouncer checks. You can have so much vulnerable code. I guarantee you there is no code review process that they go through to validate that. They don't have the team. They're not Google. They're not Apple. So this one's basically, if you want to store any secrets, obfuscate your JavaScript, is what they're suggesting to people. Oh, but wait, no, there's more. You can also load your JavaScript remotely, but because you can't grab. So they're saying if you're gonna hold secrets or any type of private keys or anything, just put it in JavaScript, obfuscate it, and you'll be good. It's not 100% bulletproof, is what they're saying, but it helps. No, it doesn't. It doesn't help at all, actually. And it gives you two apps to do that: Uglify and JS Scrambler. So I got this actually from the Ionic forum on how to build secure hybrid applications. And it has, you can't see it here, but there was 83 thumbs up for it. And I was like, oh, it's awful. It's awful because this is the type of stuff that happens when a provider or somebody that application developers look for or look to for guidance, and they're telling them, hey, yeah, do this, do that, and it's all the wrong guidance, all of it from beginning to end. So Telerik has the backend as a service, meaning you can use their web server and their SQL server. And they call it data access. So they give a disclaimer here. Telerik data access does not enforce any security permissions and will invoke any user-supplied data object code in process regardless of whether it is trusted or not. Tells you, again, it's their disclaimer, we told you so, don't blame it on us, is how they're going to point it, how they're going to look at you. So Genexus. I've seen Genexus mostly in overseas apps, whether it be South America or UK. Another drag and drop. It's been around a while, maybe I think 2011, 2010, something like that. All .NET. Actually, no, it has a bunch of different integration platforms that it can use, but they have inherent framework vulnerabilities, which is mostly around OAuth, SSL, the most important things that your apps run off of: authentication, authorization, confidentiality. So that's great. We'll go through those. Again, from their API, developer documentation, it tells you just same thing as Xamarin does for the property that indicates whether the HTTP call will be made over HTTPS. 0 if it's if HTTP will be used, or 1. And obviously it's 0. Where's the 0 here? Can't see it, but that's a 0. And that's by default. So again, yeah, they have to have their own CAs, but you generally want to have a big disclaimer of all apps should use SSL, especially when you're transmitting sensitive data, or authentication tokens, authorization tokens, whatever it may be, which is what this is here. So Genexus, like I said, they use OAuth as their authorization kind of delegate protocol here. And what they're suggesting is over HTTP, send a post request with your client ID and client secret. And also hard code that in your application here as your client secret. So in OAuth, how many are familiar with OAuth? A few? Okay, so it's kind of a complicated language as far as it's not the language, it's the protocol, but it's the framework. And there's so many different, OAuth 2, yeah. There's 2 different versions, but so client ID and client secret, this is what the authorization server will look for to give you actually the real access token or refresh token if you're making that. And obviously, when you have these hard-coded and they're telling you how to put them in the application and send it over clear text, you can get those and you can ask for refresh tokens. Access tokens, because Genexus doesn't even use refresh tokens. They use only access tokens. So once you have the access token, you don't need username, password. You don't need to log in or anything. You just pop it in, and you'll see how, I'll show you just a bit how they store it. It's in clear text. So when was the last time you guys logged back into Twitter from your mobile app? Probably not ever, because it uses OAuth and it uses refresh tokens. But in this case, it uses access tokens. But we're going to go over a couple common findings. Obviously, SSL is one of the big ones. Now, these are just specific things what to look for. Let's say when you're reverse engineering the app, when you're taking the app apart. This one specifically is for iOS. So once you get into that whole payload directory, get the application binary, pop it into something like IDA or Hopper or Radar, whatever people call it. All you got to do is search for these APIs. And so general methodology of pen testing mobile app is you get the app from the client. You then take it apart. You rename it, like I said. Pop it into Hopper. I pop it into Hopper. It's free for like 30 minutes or something, an hour. Or you can pay only $90, so it's great. And from there, you look for any type of client-side vulnerable APIs, vulnerable libraries, frameworks, third-party apps that will call this application. And for iOS, URL schemes, which is iOS application inter-process communication. Yeah, that was a mouthful, but basically so other apps can talk to a specific app. So it's like, I think I have it. It's like FB. For Facebook, it would be FB:// message equals hello and name equals Aaron, for example. That'd be a URL scheme. And that's something you'd look for, again, when taking apart an application is how those are called. And it's up to the back end to authorize and make sure and validate that the client has the permissions to call those. But for SSL, there's AF networking libraries, there's CF networking, which is here, and it gives you the ability to accept all certs and also disable SSL pinning, as well as allow all invalid certificates. Very easy to find. So this is before you even install the app on your iDevice. You're obviously going to validate afterwards, and that's like the second phase, put it that way. Last phase would be like reporting. So Android, same thing. Several vulnerabilities with Android. Generally, if you're extending the trust manager and overriding it, you're doing SSL wrong. I always search for these here. Allow all hostname verifier, and allow any type of certificate to be used. And from there, you could proxy the communication between the client, meaning the app, and the server. So one thing to know, it does not support a certificate pinning, true certificate pinning. Okay. Yeah, so something to know, again, just Cordova does not support SSL pinning. So if you're a bank app, if you're a medical app, things like that, anything that kind of holds sensitive data or transmits it, you probably don't want to use Cordova. The next section will be insecure data storage. And this is probably the biggest issue or findings that you'll locate within an application binary. And that will be, like I said earlier, encryption keys, secret keys, private keys, passwords, server passwords, API keys all the time, OAuth tokens, refresh, access tokens, and also what's stored in SQLite databases. And iOS has something called binary cookies. It's like it serializes a file, but there are free tools out there that will just decode that information and show you, hey, here's the username and password because that stuff is stored in here. For some reason, developers think that, hey, if I serialize an object, I can't deserialize it. Cache and temp are also important. Always find vulnerabilities here. And this is cached within the application's bundle sandbox within that document doctory that I showed earlier. And I always find access tokens in there all the time. Access tokens, it'll auto-log me in. It'll give me a full URL, username equals, access token equals. You won't be able to see it when you're proxying the app for some reason, but it pulls it from cache thinking that they're sneaky. And from there, you're always logged in. So here's an example of an application storing a client secret, client encryption key, client ID, as well as an Android API key for notifications, and the sender ID, all in clear text JSON, right in the application's directory. So, don't want to hard code any values, especially for every single app that you're deploying. This is a JSON file, by the way. It's not a plist file, XML file. Tools won't find things like this. You'd have to actually physically go onto your iPad or iOS device and look at the files that are stored. It may sound or may look like it's a web type of config file or just a request or response that's cached, but it's actually a config file with these type of values in there. Very easy to find, not hard at all. This example here is an application that many of you might have on your phone now, which gives you their Blowfish private key in clear text within the application's directory here. And here it's an XML file. It also tells you the database manager and what it uses, core service database. So Android, same story. Usually if you test the same app on iOS and Android, they'll have the same issues, more than likely. So it's easier to go through an Android application and find static values and find hard-coded values. Just because it's less time, and there's a lot of automated tools out there that I will show you in the demo, but which we will jump to right now. Actually, we're running out of time. But again, same issues, OAuth tokens all over SQLite. Shared preferences is what Android devices have. So that's where you'll see things like this, access tokens in shared preference, clear text. And this is from the Genexus app, where there is no refresh token here. It's just an access token. So you pop that in to your shared preferences right here, access token, you have the same access. Oh, this is a fun app. This is a SQLite database. I was testing to see what data was stored. And they stored username, password, hash password, Windows SID, if they're logged in, logged off. They stored emails, subjects, the body of the email, from everybody, not just like the person who you're logged in as, but everybody. It almost like cloned their whole database to the device in the SQLite database. So that was interesting. Again, just a brief kind of blurb about client IDs and client secrets, but we talked about that's how you're able to acquire refresh tokens. These are just what OAuth or RFCs are suggesting, and it's still the same thing, putting in the post body the client secret, which you can proxy easy, burp or zap. This just happened 2 weeks ago now. The Samsung Smart Home, Smart Things lock, they stored their client ID and client secret. And then again, they had everything they need to get an OAuth token, front access to their house, their garage, whatever it is, just because of that. So I'll be sending out the slide deck so you guys can have a look. And there's references at the bottom and links that you guys can check out. Again, another example, client ID, client secret. These are real apps that are in the wild, not vulnerable apps. These are things that I've tested and came across. Another secret token here. Sometimes they'll try to rename like a variable, or let's say it'll say just a random name like flavor equals, and it'll actually be a string, but sometimes that'll actually be the private or secret token to decrypt something before it goes into Android's key store keychain or iOS's keychain. So here we go. All right, so the three apps that I am going to demonstrate are Mobile Security Framework, Quark, and Android Bugs Framework. And we will start with Quark because it takes the longest. Sorry, guys. Just kind of want to walk through this. So it's asking me to provide the APK file here, which I will. You'll see how simple it is to conduct. This is for Android, by the way. So who created this was Tony Trummer and Tushar from LinkedIn. Tony's now Director of Security at Tinder. But why it takes so long is you can inspect the manifest here, Android manifest, and it shows you. So it's going to decompile. But why it takes so long is because it uses 3 different Java decompilers, and it parallelizes them side by side, which is JD Core, ProYocon, and CFR. And it compares the values between all 3 of them and gives you the best output. So we'll come back to this because it takes a while, like I said. We'll go to Mobile Security Framework. By the way, they're all Python applications.
Can you make the font smaller? Just kidding.
My bad. Yeah. This one runs off of Django, the Django application. Really fast, by the way, you'll see. So right away, it gives you a description of activities, receivers, and providers, the main functions of an Android application. But we'll just jump down. We'll talk about this in a second. It has the ability to fuzz APIs and also fuzz intents. So it's pretty cool. It's a OVA VirtualBox image. I don't have time to demo that, but the cool thing about this is it tells you right away like what to look for. Meaning, it gives you the certificate, gives you the permissions here. This one does not have, this is an insecure bank application. I will show you a real one in just a second that I found last week, and I'll show you how easy it is to find something. Let's do that now. Let's go to real app. And Mobile Security Framework supports Android apps and iOS apps. The only framework that I know that can even test or automate the decompilation of iOS apps. So here's a real app. I got a new car recently, and I want to check it out. So it's a Subaru car. And again, permissions. Here's the Android API that I want to show you guys. And it tells you just a general type of services and API endpoints, and hey, maybe you should look at this. It has logging information, logging APIs, and these are potential like passwords or things that are also logged. But we're going to go to the security analysis section. So it checks the manifest and gives you kind of its opinion on the issues it's found. But here's where I kind of want to show you, and you have where the app can write to an external storage, whether it be SD card or somewhere else. And then the encryption it's using for anything within the shared preferences. Here's talking about what the logs, the app logs information, storage sensitive information should never be logged. But I always look here. Files may contain hard-coded sensitive information like passwords, keys, things like that. So the first thing I did was, okay, well, let me go to the beginning. All right, cool. I can get some, a little bit of info. Some tokens, last successful. Okay, you get a, maybe it's running something locally. I don't know. Sure. Then usually I'll just kind of go through the third one, kind of pick random ones here, and then see, hey, this config file, what is it? Not too sure yet. Might use WebSockets. Looks like it does. But here's a cool one. Right away, see some interesting values here. Oh, sorry, it's a responsive Bootstrap application. So but you can see, again, another case of private keys being stored statically on an application. You can find this within 5 minutes. It's not hard at all, and you can see how fast it decompiles it. And the cool thing is, with Mobile Security Framework, you can also check its Java code. So let's say I want to find password or secret. Cool. Not hard at all, right? So here they are, hard-coded values. Right here. So that's great. I actually didn't know about that till now. But we'll go back to check on Quark here. Because now it's decompiled and now it's going through some checks. And we'll have a look at Androbugs. Python again. And it's going to want a file, so I'll do -F. Let me zoom in for you guys. And then still no. Give it the path of the APK. And a lot of checks for Android bugs or SSL checks, any type of secret codes in the manifest, any type of vulnerable APIs for JavaScript, add JavaScript interface where you can basically remote code execution into the mobile device and Java objects, and web view vulnerabilities as well. So this is pretty quick. It's not as long as Quark, which still takes a minute. But we'll give it a second to do its thing. It'll spit out a text file, and the text file will have everything you need. So just with these three tools, you can correlate and actually, have the good portion of your test and know what to look for before even hitting their infrastructure, as far as the backend, API backend, whatever it is. And that's the beauty of mobile pen testing. You don't have to really wait for the engagement to start, or even to research an app. You can just pull it down, look at the code, look at vulnerable APIs, look at the hard-coded values, and take advantage of that. So we'll go through the text file. Just so you guys can see, if we can get you to see it. All right, you can see that, right? More? All right, it checks if debugging is on. In this case, I use a vulnerable app, so debugging is on. It checks for permissions, and the cool thing, it gives you descriptions, and so does Quark. Mobile Security Framework does not, so it's mostly based upon your knowledge for the most part, or the developer's knowledge. So Android Manifest content provider, so if they export it, so you can export activities, content providers, and broadcast receivers. And export means that you're giving a third-party application on the device access to your device, your function, whether it be content provider activity. So if you're exporting a transfer page for a mobile bank, for a bank application, you don't want it to export the exact page of the transfer that's occurring. So as an example. So here's an add JavaScript interface vulnerable API I was talking about. And it gives you the CVE and everything. Little description. Some dynamic code loading. And again, if it's accessing external storage, meaning the SD card. The cool thing, it gives you like the Smalley snippets, but you can decompile the app, open it up in JD GUI, or use Mobile Security Framework to search through it and get more of pseudocode and see the Java classes. So you can read it like in better English. So the broadcast receiver is exported as well. And again, it gives you a little description here. So let's check back on Quark. Looks like it's still doing its thing. Almost there. But the cool thing with Quark too, not only does it give you a report, but it gives you an attack APK application to exploit the vulnerabilities that it's found. So it relies on Android's SDK. For Mac, you could just brew install it, easier than going through the Android site, and install on your device, and it runs all the exploits for exported activities, exported content providers, and Tony, how he created it was just using templates for Android VMs and emulators, and basically put the values that they found for results of vulnerabilities, and put them in and build an APK for it. So I'll wait just a second here, let this finish up. It takes maybe, I think we started this maybe about 8 minutes ago, so it takes a bit compared to Mobile Security Framework and Android bugs. But again, a lot of the heavy lifting has been done by looking at client-side code, and then after, once you see vulnerabilities, you want to go ahead and install the app and test dynamically, as well as runtime. So Tony created this. He was telling me he created this because he didn't want to use Drozer. If anybody has pen tested in the mobile space, Drozer is just a malicious application which has really shitty documentation. So he wanted to create one. See, here we go. We have a prompt to create an application. Can I? Oh, you can't see it. So one to create a custom APK. Let's just do that just so you guys can see. It doesn't take very long. And then it's going to spit out a report, HTML report. You can actually configure it to auto install on your device too, which is pretty cool if you have ADB. Uh-oh, no report here. Here, we'll just look at an old one. There is one. Cool, yeah, we do. So again, it gives you like a little dashboard with some vulnerabilities, things to look at, warnings, some other, let's say like web views, for example, web view vulnerabilities. If it works, because of course it doesn't. All right, well, typically you'll have for like web views, let's go back here, because it shows you. This is actually everything that goes into the HTML doc file. And it gives you the ADB commands as well. You can't see this. But essentially, he gives you links here where you can test these vulnerabilities and if it's vulnerable to any type of web view or JavaScript injection or JavaScript configuration on the mobile app. So SecBro is Tony's site. But you can just pull these files down and check yourself. Not very hard. But I want to show you guys the ADB commands. Here you go. Change password. Here's a string how to do it. So ADB shell AM is activity manager start -n, and it gives you the command and the string. But if it was working, I would show you how the report would look with the suggestions and the exploit code as well as the exploit APK. But having issues on that end. But you guys can see how simple it would be just with mobile security framework in itself. Again, the cool thing that I like about it is also the URLs it talks to, and the third parties, and the ad agencies, and whoever else will all show up here as well. And if they've taken code from someone from Stack Exchange or something, you can see via strings. They give you strings here, and a malware check, which you can turn off. So obviously strings, any type of binary, whether it be mobile or thick client, is always a good place to look at. Kind of short on time, but does anybody have questions before I close out? Because still a few more slides, but let me just go through those really quick here. So the reason why you want to use these tools, pen test, you usually only have a week to pen test an app. So you want to be most efficient of your time. And again, you're mostly focused on client-side issues, not web-based or web services that much or API, obviously unless they pay for that, but it's usually not the case. While a security researcher has unlimited time, and everything is fair game. So here are the tools that I use pretty often. All open source and free. IDB, MobSF is mobile security framework. Ccrypt for runtime and Frida for runtime, and Cydia tools for the devices on. For the tools on your iDevice. Here are the Android ones. Quark we went through. Android bugs, lobotomy goes through runtime and storage API vulnerabilities. And Inspecage runs on the device. And again, MobSF is both Android and iOS. It's cool. It's all static code analysis. If any of you know Jason Haddock, he's a cool guy. He has it on his GitHub. It is pretty good. But again, it has a dynamic analysis, MobSF does feature. And again, tools don't find everything, trust but verify. There's plenty of things that tools, like I said, I've said plenty of times, that tools don't find. You have to take a look at within runtime when the application's installed. So here's my Twitter. I'll send out the slides so you guys can have a better look. And any questions, you guys can also follow me for my research and things like that. Have time for questions? I think I'm the last one, so I may have time if anybody has questions. No questions? Okay, cool. Thank you.